Good morning, student. Today, our chemistry topic is P block element, a part of inorganic chemistry of +1. बेटे जिहड़ा पी ब्लॉक एलीमेंट है इनकी इंट्रोडक्शन ही अपने सिलेबस च है +1 दे विच और इनका जिहड़ा मेजर पार्ट है वो +2 दे विच है। ठीक है, तो आप इनके जर्नल ट्रेंड थोड़े स्टडी करांगे पी ब्लॉक दे विच और बड़ा ही इंटरस्टिंग है और बड़ा ही थोड़ा जिहा टॉपिक है। इनका मेन पार्ट जिहड़ा है वो डिलीटर सिलेबस भी आ गया है। ठीक है, नाउ द क्वेश्चन राइज, what are P block elements? P block elements are those in which last electron is added in p orbital of the valency shell. P subshell can have maximum 6 electron. Therefore, P block contain only 6 group from 13 to 18. 13th group element is known as boron family because its first element is boron, and 14th group element is known as carbon family because its first element is carbon. Element of 15th group is known as nitrogen family or panicogen. They are mostly poisonous element like nitrogen, phosphorus. Nitrogen is not a poisonous, phosphorus is poisonous, arsenic is also, rest elements are all poisonous. Panicogen. And element of 16th group is known as oxygen family. Its first element is oxygen and they are also known as chalcogen. Chalcogen mean ore farming. Most of the metal exist in nature in the form of oxide or sulfide. For example, ore of iron hematites Fe2O3 is oxide or sulfide. Chalcogen mean ore farming. Elements of 17th group are known as halogen. Halogen mean salt producer. Most of the salt, for example, even common salt, sodium chloride, is a salt of halogen. Sodium chloride, chlorine is a halogen. And element of 18th group are known as noble gases. They are known as noble gases due to their less reactivity. They are very less reactive. ठीक हो गया बेटे? ये तो इंट्रोडक्शन सी बेटे पी ब्लॉक दी. Now boron family. Boron is semi-metal और its electronic configuration is 1s2, 2s2, 2p1. It has 3 electrons in the valency shell, therefore they form 3 covalent bond. मतलब boron is mostly trivalent. Now the very important question, halide of boron. Boron react with the halogen. Halogen mean fluorine, chlorine, bromine, iodine. Their compound with the halogen are known as halide. For example, BF3, boron trifluoride, boron trichloride, boron tribromide, boron triiodide. Their compound are known as halide. Boron trihalide are electron deficient species. But a very important question है. This question is very important. Why boron trihalide are electron deficient species? You know, electron deficient species are known as Lewis acid. And now the question arises, why boron trihalide are Lewis acid? Boron have 3 electrons in the valency shell and it can form 3 covalent bond with halogen atom. बेटे ना X जो मैं लिखता हाँ ना, X का मतलब halogen atom है. It may be fluorine, it may be chlorine, it may be bromine and it may be iodine. Boron can form 3 covalent bond with 3 halogen atom and there are only 6 electrons in the valency shell of boron. It needs 2 more electrons to complete its octet, and BX3 is electron deficient molecule and it has a tendency to accept pair of electron. Due to this tendency, it acts as a Lewis acid. A Lewis acid एक्ट करेगा. BF3, BCCl3, BBr3 and Bi3. They are all Lewis acid. Now the question arises, which of them is strong Lewis acid and which is weak Lewis acid? According to electronegativity factor, fluorine is most electronegative halogen and iodine is least electronegative halogen. According to electronegativity factor, BF3 should be strongest Lewis acid and BI3 should be weakest Lewis acid. But actual order is reverse. Bi3 is strongest Lewis acid and BF3 is weakest Lewis acid. This abnormal behavior can be explained by taking into consideration the new and different concept which is known as back bonding. Now the question arises, what is back bonding and how it decreases the acidic character of the boron trihalide? To explain this, let us take the example of BF3. Boron have electronic configuration 1s2, 2s2 and 2p have 1 electron. In excited state, 1 electron from 2s migrate in 2p orbital. Now, in excited state, there are 3 half-filled orbitals, and these 3 half-filled orbitals intermix and give 3 sp2 hybrid orbital having identical shape and equal energy. We know sp2 hybrid orbitals are trigonal planar. Therefore, geometry of BF3 is also trigonal planar. And there is one vacant 2p orbital which is perpendicular on the plane of the molecule, one lobe below and one above the plane of the molecule. And fluorine have completely filled 2p orbital. Completely filled 2p orbital of fluorine overlap with vacant orbital of boron. It is called p pi p pi back bonding. Due to back bonding, electron deficiency of the boron atom is somewhat compensated. As a result, St character decrease. Back bonding is depends upon the length of the bond, and length of the bond depends upon the size of the halogen atom. Fluorine is smallest halogen atom, therefore back bonding is maximum in BF3. That is why BF3 is weakest Lewis base. And due to large size of iodine atom, back bonding is minimum in Bi3. That is why Bi3 is weakest Lewis base. And order of St character is BF3 weakest, then BCCl3, then B, Br3, and last maximum Bi3. ठीक है बेटे। जो नैक्सट बच्चों जोड़ा है टॉपिक है अपना प्रॉपर्टीज ऑफ कार्बन एंड कंपाउंड, ये नैक्सट वीडियो बेटे आप बनावांगे।